Okey, baik. Assalamualaikum warahmatullahi wabarakatuh, dan salam sejahtera. Okey, kami daripada kumpulan yang keenam akan membentangkan tentang tajuk grup projek kami. Dan kami akan menggunakan Rivet Gun. Baiklah, ini adalah grup member kami. Dan yang pertama adalah saya sendiri, iaitu Muhammad Afiq Irfan bin Syarul Nizar. Uh, dan bernombor metrik AN210056. Dan seterusnya adalah Muhammad Nasim bin Sulaiman yang bernombor metrik CN21023. Dan yang ketiga adalah Muhammad Hazim bin Kamaruzaman yang bernombor metrik DN200054. Baiklah. Seterusnya adalah objektif bagi kami punya grup projek. Dan yang pertama adalah to study, learn and understand about the concept of electropneumatic and safety procedures for handling the system. Okay, yang kedua, to analyze the operation of this control circuit. Dan yang ketiga, to build the displacement step diagram based on the operation of cylinder. Dan yang keempat, to identify the problem and propose a solution based on the circuit failure.
Okey, Assalamualaikum. Nama saya Muhammad Nasim bin Sulaiman dan saya akan terangkan berkaitan circuit operation and explanation. Okey, ini untuk circuit kami. Okay, firstly, I will explain briefly on the initial condition of the circuit. Okay, and as you can see, we have the three cylinder in all of that in the rest position. Okay, looking at the Fluidsim circuit, we have the push button SF1, and then we have the KF3 contact point and KF1 relay coil. We also have the KF1 contact point here to make the latching. And then we have the KF1 contact point at node 3 and to activate the MB1 solenoid valve. We have also have the BG0 magnetic proximity switch at cylinder 1 to activate the timer 1 for 1 second. We also have the timer 2 contact point at node 5 to activate the MB3 solenoid valve at cylinder B. Then we also have the BG2 and we also have the BG2 magnetic proximity switch at node 6 to activate the MB4 solenoid valve for cylinder B to retract. And then we will have the T1, the timer relay contact point at node 7, and also have the T2 timer contact point and then to activate the MB5 solenoid valve to make to extend the cylinder C. And we also have the BG5 magnetic proximity switch at node 8 to activate the timer 2 for 1 second. And lastly, we have the timer 2 contact point at node 9 to activate the KF3 to deactivate all the circuit altogether. Okay, in the pneumatic circuit, as you can see, I use the double acting. Three of them use the double acting cylinder, and the first cylinder A use the solenoid valve 5 2-way. Also the cylinder B and cylinder C. Okay, this is for the first operation when the push button SF1 is pressed. Okay, when the push button SF1 is pressed, the KF1 contact the KF1 relay will energize and change the contact point of KF1 and activate the MB1 directional control valve and extend the first cylinder to the max position. And when in max extend position, the BG0 magnetic proximity switch are activated and start the timer for 1 second. After that, the timer contact T1 activates the solenoid valve and before and makes the cylinder C extends. Next, when the cylinder C at maximum extend point, the magnetic proximity sensor BG5 activates and activate the timer relay T2 for 2 seconds. Then, after 2 seconds, the timer relay contact T2 at node 5, 7, and 9 activate, which will turn on the MB3 solenoid valve and extend the cylinder B. Timer relay at node 7 will opens and deactivate solenoid valve MB5. Timer relay at node 9 will activate the relay coil KF3 and changing KF3 contact point node 1 and thus deactivate all the circuits. And lastly, when cylinder B reaches maximum extend position, it will activate the magnetic positivity switch BG2 and retracts back to its initial position. And then that's how the circuit ends. Okay, that's all for me. Thank you.
For our case study, in an industrial conveyor, when an object reaches a riveting machine, the object will stop at the end of conveyor. When push button SF1 is pressed, the double acting cylinder A will extend to push the object to riveting point. Then cylinder C, which hold the riveting machine, will extend down to reverse the object for 1 second. After riveting, cylinder C will retract and cylinder B will extend to push the object to the end conveyor. And next, for our discussion, a rivet gun, also known as pneumatic riveter, is a type of tool that uses air pressure to drive rivets into material for fastening purpose. It is commonly used in construction and manufacture to join sheets of metal or other material together. The total consists of a gun-shaped body with a nose piece that hold the rivet in place, and a trigger that activates the air pressure to drive the rivet into the material. The advantage of electropneumatic rivet guns is it can be faster and more convenient and manual or air power rivet guns, especially for large scale projects that require a high volume of rivets. Electro-pneumatic rivet gun can be expensive compared to other type of rivet gun. The cost of electro-pneumatic rivet gun can vary greatly depending on the size and features of the tools. But in general, these tools tend to be more expensive than manual or air power rivet gun due to their advanced technology and increased capabilities. And lastly, for our conclusion, we can conclude that the project is about pneumatically operate rivet guns in industry production lines. From the project, we can benefit our industrial production that depends on it such as vehicle manufacturing. We use the combination of many components in pneumatic such as solenoid valve, timer, and sensor to make it function as needed. Thank you.